The other question we're going to look at this week is question 6, which is problem 9 on page 575 of the textbook. So we have a 2-meter long string, and it's fixed at both ends, and we're tightening it until the wave speed is 40 meters per second. And the question asks, what is the frequency of the standing wave that's shown here? Now, we know that our wave speed is equal to our wavelength times our frequency, so that's going to be a useful equation to use. The problem is we don't yet know what our wavelength is, so our first step is going to be to find our wavelength. Now, we learned in recitation the other day that for a standing wave, wavelength is equal to 2L over m. L is our length of our rope or string, and m is the number of half wavelengths we have or the number of antinodes we have. You can think about it either way, they're equivalent. So we have 1, 2, 3, 4, 5, 6 half wavelengths or antinodes. And so we're going to have lambda is equal to 2 times, we said our length was 2 meters, so 2.0 meters, divided by, and we have 6 half wavelengths. So this is going to give us lambda is equal to 0.667 meters. So that's our wavelength. So now to find our frequency, we know that our wave speed is equal to wavelength times the frequency. So if we want the frequency, we're just going to divide both sides by wavelength. So we're going to have frequency is equal to v over lambda. So our wave speed we said is 40 meters per second. And we're dividing that by about 0.667 meters. Meters in the numerator and denominator are going to cancel, so we're going to be left with units of 1 over second, or hertz. And so this is going to work out to be about 60.0 hertz. Or if we want to end up rounding it to just 2 sig figs, 60 hertz. And so that would be the solution for question 6.